In this video, we will use linear programming to solve applications. Here we have systems of equations, and then an objective function is given. We need to solve this up and find the vertices and use the objective function to find maximum and minimum values. Basically, this is done by graphing. Now, what do we graph? We need to understand each equation. See, whenever you have y is less than or equal to 3 and greater than or equal to 1, see the y-axis. Where is 1? Somewhere over here. 3 can be over here. Just draw straight lines. Okay, it must pass through 3. That's wrong, but anyways, this is a line, and over here there is one more line. And now, all the region within that, because y is in between. Otherwise, if you split this out, what is it? Y is less than or equal to 1 is less than or equal to y, and y is less than or equal to 3. This means y is greater than or equal to 1, isn't it? The equivalent. Because the bigger side is opening towards y. So 1 is over here. Everything above, because greater than or equal to means, or greater than symbol means upside. Anything, just point a point and make it upwards. What about this one? Less than is down. So this is the solution region. But we have two more equations over here. So here it's in the slope-intercept form. You can use the calculated table method and find the points if you want. Mode 7, put this equation and you get the points. That is also possible. Or just basic understanding is known, right? Y is equal to mx plus b. The slope is 2 and the y-intercept is 1. So it will start over here and it's a positive slope. So it will go upwards, something like this. That is just a rough figure. Okay, I know there will be some vertex over here. And then what about this point? Here we know it will be x is at y, so it will go to the other side. It will be 2y less than or equal to minus x plus 12, and we divide everything by 2. What do we get? We get y is less than or equal to minus x plus 6. This is the slope-intercept form. Now I can tell you, okay, this is having a y-intercept at 6 and it is having a slope, negative slope. That's half over here. So it'll go something like this. So there will be one point over here. And what about over here? This is also a point. Now we need to see how these equations work. Look here, y is less than or equal to. So which is this line? At this one. I'll touch a point here. Less than means it's downwards, so it should be all this region. What about this one? Here also, it's less than. So I'll touch a point here and it should be down to the line. If it was greater than, it would be above this. Above. If it's down. See, you have any line? If it's less than, then it will be down, or less than equal to. If it was greater than, it will be up. That's the only thing. So now I know these are the 4 vertex points. Now how do you find these vertex? If you have the 4 options as the vertex, you can easily figure out this is going to be 0, 1. This might be something like 2 and 3. X might be 2 or 3 over here. That's how we can figure out. But the actual way is simple. What is this equation? This equation is this one, right? The first one. Y is less than or equal to 2x plus 1. Which lines is it touching at? It's touching this line and this line. So we need to find the intercept. You can use the calculator over here, or you can just see over here. What is this particular line? It is y is less than or equal to 3. Solve this up. When you solve it, what's going to happen? Just equate 3 over here and solve for the x value. It will be 3. I will just make this as equal to, you don't put inequality. You can just solve it as equation. Now take this 1 to the other side. It will be 2 equals 2x and it's divided x is equal to 1. So this point is at 1, 3. Because I know the y-axis already. This is 0, 1. What about this one? Now we need to see which is this equation. This equation was x less than or equal to minus x by 2 plus 6. Now substitute the y values. Over here the y value was, this is y is equal to 3 and y is equal to 1. So we will have to do both the substitution. Over here it was on the axis. It was easy. Over here I will first substitute 3 and solve. Minus x by 2 plus 6. You can make this as equal to sign. 6 goes to the other side. I'll solve it over here. 6 when it moves to the other side will be minus 6 plus 3, it's minus 3 equals negative 6 x by 2. Take it to the other side, it will be minus 6 is equal to minus x, both minus changes, it will be x is equal to 6. So this point is 6 comma 3, x-axis at 6. What about this point? Substitute over here, instead of y as 1, minus x by 2 plus 6 goes to the other side, be minus 5 equals minus x by 2. Take this to the other side, minus 10 is equal to minus x, x is equal to 10. So this point is 10 comma 1. This is how we find the vertices. If you graph it, you will find the vertices, but we are not doing any accurate graph. They have not asked for graph, they have just asked for maximum, minimum values, right? So this is how we find the vertices for any graphing. This is a rough one. Let's just look at the vertices over here. You can see over here, that's the vertices we also got. This is 6 comma 3, yes, that's the exact, all the points are correct. Now once we get these vertices, we need to substitute back into the objective function. Now that can be done easily in calculator, I'll show you now. What I do is I put the objective function and leave the x and y in brackets, blank. Now I will choose the first point. What is the x value? It's 0 and over here 1 and equals, this is the 1. At this particular point it's 1. Now just change those quickly to 3 as y and x is 1. And then what do we get over here? We get 6. So this is 1, 6. We need to write them down. Why? Because we need to find where it is maximum and where it is minimum. So both are required. Now then, I will just change it to the other 2 points. Over here, the y is same, only this value changes. It's 21. So this is having a bigger value. And lastly, we have to substitute 10 and 1. This will be 10 and this will be 1. So the answer is 31. So which is having the maximum value? So maximum value is over here, minimum value is over here. Now if you're thinking why I could not use the variable x, I can use variable x, but there is 2 unknown variables. That is not possible in the calculator. So we manually type the xy values and you can see the maximum 31 is at what? 10 comma 1, and the minimum we got 1, right? Over here 1 is written 0 comma 1. This is how we solve these type of problems. Here you need to know the basic graphing and then only solve it. Now there's one more thing. Here you will have 4 options, isn't it? You can try substituting this x and y values in the equation. If you type this 10 instead of x and solve and y as 1, you will get 31. This will match. And the minimum also should match. That is one way to check the answer. But what if they have given you certain other equations which will also be true, with say 81 at different 2 points? Because without graphing, you won't know whether these vertices are correct or wrong. So if you have to find the vertices, you will have to do the graphing. There is no other way. So that is why it's better to understand the graphing first and then do it. But in exam, if you're really not getting it, try checking all the options, put the x value, put the y value, and check whether it's matching. And if others are not matching, then this will be the correct answer. But if they give you another equation which will give you a proper matching one, you can't be sure which is the maximum or minimum. So that's the thing. All these problems are just the same. Here the change is, it's in terms of x. X is less than or equal to 4 and x is greater than or equal to 1. Now in this case, you can see over here at 1, there is a straight line. This one, okay? And what you need to do is, x is greater than or equal to 1 means it's a right. And here x is less than or equal to 4 means left. Then all the others in slope-intercept form, this would mean at 4, see this line, less than or equal. So it's down, and what about this? It's greater than or equal, it's up. So this is the solution region. You need to put them up in this objective function, all the vertices, and find the maximum and minimum, and these are the answers. This problem is also similar, but here you can see it's x and y. So let's see, x is greater. Where is x2? Over here, this one, to the right. And what about y greater than or equal to? So this is the y-axis, above. Greater means up or right. If it was less than, it's down. For x less than would be left. Now let's write these in standard form. Here it will be y less than or equal to minus x by 2 plus 3. I've just directly done this. You have to do one step at a time and you will get this answer. What is the intercept here? 3, and the slope is negative, it's going down. And it's less than or equal to, y is less than or equal to, this goes down. What about this equation? I will take y to the other side and bring 7 over here. It will be 2x minus 7 less than or equal to y is greater than or equal to 2x minus 7. So minus 7 is the intercept, y-intercept. Positive slope, it's going upwards. This is the line, it's greater than. So I catch a point and upside. So this overlapping region is the solution set. And these are all the vertices over here. This is how we put the vertices back to the objective function and get the maximum, minimum. If it is graphing, it's pretty simple, but you have to find the maximum and minimum value. So you need to do the graph and then find it out. So these are all the vertices. Over here, there are a bit more equations, 3 equations over here, and then 2 lines. You will have this one. So one important thing, because you need to find maximum, minimum, they don't leave it open. It'll be always an enclosed shape. So if you don't get it, just double check if you have written it properly in the standard form or the slope intercept form. Double check it and then get this graph. Now, in order to find the vertex point over here, just see which are the 2 equations, this and this. Write it in terms of standard form. Ax plus bx equals c, ax plus bx equals c. In the calculator, you need to press mode, phi for equation and 1 for simultaneous equation. Now this must be in standard form. Here, since the intercept is 3, 2 divided by, this is the equation for this line. Okay. So what you do is 1, 2 and 6. Now what about the next equation? This is having an intercept of 1, so it must be this one because 2 divided by 2 is 1. Now write the coefficients of x first. Remember, a is always x. If you write 2, it's wrong. So I need to write minus 1, then comes 2, and lastly we have 2. See, ax plus by equals c. Now the vertex is 2, 2. That's how we get it. Whenever we have 2 equations, just put the 2 equations in the calculator in standard form and solve it out. And even over here, you can easily solve them up. When it's a straight line, you just substitute. Over here, we know x value is 5, so substitute over here x is 5 and solve it up. Now, this is x is equal to 5, right? If I substitute in this equation, x is 5, it will be 5 plus 3, 8, so y value is 8. And x value is 5, obviously, because we are considering x is 5. This is the intersecting point. So it's not that hard to get this graph. Once you get the graph, you need to put these vertices, all the 4 vertices, back to this equation and find the maximum and minimum. It's just a lengthy procedure, but it's a straightforward problem. Please try all these problems by yourselves and check for the answers. The graph is there and also the answers are there, and you can easily solve them up. That's it. Please do solve all these problems by yourselves. Please do graphing. The more you graph, the more easier it becomes. And if you have any doubts, please post them in the comments. I will try to get back to you very soon.